Hello and welcome to today's Saratech enablement session. My name is Andrea Hall and I'm the Customer Relationship Manager at Saratech and I'll be your host today. Presenting we have Daniel Rubio. He is an applications engineer here at Saratech and he'll be talking to you about linear contact in Femap. Our sessions run about 30 minutes each. Sometimes we go over a little bit. And they are all recorded and posted to our Saratech YouTube channel. So make sure that you check out our past sessions on our YouTube channel. We're here twice a month and we meet just to learn about tips and tricks and new and old features that help you in your everyday tasks. This is an open forum, so if you have questions or comments during the presentation, please type them over in the chat box or the questions box over on the right-hand side. Usually we allow questions throughout the session, but today we are going to hold the questions until the end of the session just because we have such a high attendee rate today, which is wonderful. So we will try to get to every single one of those questions towards the end of the session. And with that, I'm going to pass it over to Dan.
Thanks, Andrea. Like Andrea said, my name is Daniel Rubio. I'm an application engineer. I've been with Saratech about 7 years now, 7.5. I've mainly been focused on Solid Edge and Femap with a little bit of NX-Nastran, NX-CAE, or SimCenter 3D and SimCenter Motion as well. And I did receive my bachelor's and master's degrees in mechanical engineering from UCF in Orlando, Florida. So for today's agenda, we'll be doing an overview of contact. So we'll be comparing glued versus linear contact. Then we'll talk about the differences between linear versus when you may need to step up to nonlinear. Then we'll talk about the connection properties, regions, and connectors, which are all required if you're doing this glued or linear contact. And in doing so, there's both automatic and manual methods to create all of these connections. And of course, we'll wrap up with a summary at the end after the demo. In some models, we need to model boundary conditions that exist when one part just touches another part or when the boundary condition can only take loads in one direction, for example. So early on in Nastran, gap elements were actually used for this purpose, but they only work point to point and usually require a non-linear solution as well. Nowadays, Nastran has a 3D surface-to-surface contact method, which can run in a linear solution. It does go through iterations to calculate the contact, as we'll see in the demo, but there is no geometry or material nonlinearity involved here. Now, for many problems, this is sufficient to accurately model the parts, but in some cases, you may need to, of course, step up to the nonlinear world. If you want to read up more information, you may want to look at Chapter 19 of the Nastran User's Guide. That'll tell you all about contact. All right, so one important thing here, which I mentioned, is using contact in a linear static analysis assumes that displacements are small. Contact can be used for larger displacement problems using the advanced nonlinear solvers, 601, 701, and also for other contact types where the contact can change with loading or time. So think sliding contact. Contact can include point-to-point, like the gap elements I just mentioned, or surface-to-surface, surface-to-solid, or solid-to-solid contact. One important thing here is the basic nonlinear solution 106 only supports gap and slide line elements for contact, not surface-to-surface linear contact. So here's a quick representation of contact and how it's defined. The contact solution searches and detects when a pair of element faces actually come into contact, and the contact conditions prevent the faces from penetrating each other. But it does allow some finite sliding, and you can also add friction here as well. So there are two types of contact that we're talking about here in Femap with NX-Nastran. You have glued contact, which joins components as if they were modeled using the coincident node, coincident merge method. So these parts are considered to be rigidly connected. This is a very nice and easy way to join dissimilar meshes because the grid points or the nodes on the glued edges don't need to be coincident. And it does correctly transfer the displacements and loads, so it gives you accurate stress and strain results at the interface. Now, the second type is contact, often referred to as linear contact, so it doesn't get confused with the surface-to-surface contact, which is nonlinear, like I mentioned. This linear contact can only be used in the linear solutions like linear statics, modal, and so on, and also the advanced nonlinear static solutions, but not the basic nonlinear like I mentioned. So it's a little counterintuitive, but it's just how it works behind the scenes there. Now, as with any linear solution, you do need to be mindful of the constraints. You want to make sure the model is properly constrained so you don't have any rigid body motion, so parts aren't just flying off into space. Here you can see a simple image just showing a glued contact example. So here this is an image of a modal analysis. So you can see a constraint on the left end. And if these parts are glued at the interface at the center here, you can see it's basically a cantilever beam, right? So they're basically welded together so you get the right end, this typical diving board example. Now you can also step into a linear contact. So this is where, in this case, we have the two plates here are separate. Each end, the left end and the right end here are constrained, and at the interface in the center here, we have actual contact. So as you can see, there's a lot more deflections here since there's some sliding going on. So much different results here depending on what exactly you're trying to model. All right, so as for these solution sequences, linear contact is available in, like I said, most of the linear ones, linear statics 101, your normal modes for your natural frequencies, 103, buckling, 105. Also the modal frequency and transient responses, 111 and 112. And also the multi-step nonlinear 401 and the advanced nonlinear 601 and 701. So notice, again, the basic nonlinear 106 is not included there. Glue, on the other hand, is available for almost everything except a few here. So edge to edge, it's compatible with all solutions except some of those aeroelastic solutions and 701. Edge to surface, again, very similar compatibility there. And surface to surface, again, all of them except the aeroelasticity and the advanced nonlinear 701. So NX-Nastran defines the contact capability as surface to surface, which is what you may hear or see in Femap, but really it's element face to element face. In Femap, you can pick surfaces for the contact regions just like we do for pressure loads. So it makes it very easy, and Femap automatically applies it to all of the element faces on those surfaces that you pick. As for the element types, surface-to-surface contact can be used on the faces of the following elements you see here. So for shells, your trides, your quads, and so on. And for your 3D solid elements, your hexahedral, pent, pyramid, and tetrahedral, of course. All right, so the Femap contact setup commands are available in the Connect toolbar menu from the top of the window or right from the model info tree. Like most of the commands in Femap, you can right-click in the tree and create new ones on the fly. There is an automatic option that works very well for simpler models, but it may get a little complicated if you have many parts, especially with varying thicknesses and gaps and so on. So you may want to just create them manually in those cases. But in any case, 3 items are required. You need a connection property, at least 2 connection regions, which are the surfaces that are coming into contact, and a connector, which is going to link all these together. So your 2 regions and then which property you're using. There is a shortcut in the connector form. There are buttons to create new properties and regions on the fly. So you can really do the entire setup from the one connector command. And I'll show you guys that in the demo. Here's what the contact properties windows look like for linear contact and glued contact on the right. So as you can see at the very top right of the window, you have the connect type, which is where you choose if you want contact or glued. And then once you do that, you want to click the defaults button at the bottom left. So that is going to work very well for most situations, but you can of course customize these settings if needed. Now for linear contact on the left, the couple options I'll mention are friction, which of course just depends on the materials and whatever value you like to specify there. You also have the maximum contact search distance over there to the right. So right there it's 50.2. So, you know, maybe that's millimeters depending on your units. Of course, you want to limit that to, you know, just above the actual gaps that you have. You don't want to just throw a huge number in there. Of course, it's going to, one, take very long to calculate. Two, it might, you know, cause things to contact that you actually don't want. Then you have the initial penetration option, which can be set three ways. You have the first option is calculated. That is just going to calculate the distance, and you can include shell offset, which is the next option I'll mention here. This can also preload if you have a press fit situation, if you have the grids overlapping. The second option here under initial penetration is calculated zero penetration. So it's the same as the first one, but it's going to set any preloaded areas to zero. And then the third option there is a zero gap penetration. That'll set the gap to zero for all contact elements. It basically ignores the geometry. And that third option is good for, let's say, cylinder and a hole type of contact. Now the next option, shell offset here just below, that can you can use that setting to include half the thickness of plates or shells, which is a default, but you can turn that off if you have different offsets manually applied. Now let's look at the right, the glued options. There's of course much less, as you can see. Most of those get grayed out. The main one there really is just a search distance at the bottom. As you can see, 0.05 in this case. So let's talk about regions now. Here you can see the connection region dialog. So you have a few different options here. First is, of course, selecting the entity. So you have surfaces, elements, or curves in this case. You also define which side, let's say positive or negative, which is very important with this checkbox here. And with the region options button, you can add an offset if you'd like. A couple notes here, NX Nastran only supports deformable contact. You can do rigid contact in the advanced nonlinear solutions. And also the property part contact option here that's grayed out is supported by some other solvers such as Abacus, Mark, and Atlas Dyno. And again, I just want to mention this positive side option is very important. I'll talk about that on the next couple slides. But really, all you do here in this window is select, in this case, the surface, for example, you want to create a region on. So in this case, 146, or you can click the multiple button here to add many surfaces in one shot. So now let's look at how these regions are defined. Basically, you have a positive or negative direction for a region, so similar to an element or a surface normal. And the idea here is they need to face each other. So here on the left, we have these two blue elements. So if we're looking at the bottom element or region, if the positive direction is up, we can see that that's correct. So we want to set that as positive for this region. Now on the right, for whatever reason, let's say the normal direction was facing down. So what we want to do here is set that region to negative. So we'd want to uncheck that positive side box, and that'll flip it negative, so it can properly point to the other element that it's coming into contact with. So to show these region normals, there is a couple of ways. You can go to the Windows Show Entities command, Shift F12. That'll bring up this window, and you can click region and then the Show Normals toggle. You can also do this very easily right from the model info tree, which I'll show you guys. In the highlighter tool, there's an option to show normals. So here's just an example of what that looks like. We have a plate here. We can see the yellow highlighted arrows showing the normals. But what's nice is that Femap makes it very easy to fix this. So if they needed to go up instead of down, you can simply right click on the region and click reverse, and that'll flip that direction for you. And this is a very common source of error. If the normals aren't facing each other, the contact won't be recognized, and you'll see axis pivot ratios, fatal errors, basically meaning the parts aren't connected and they're flying apart. And the reason these normals are important is that's exactly how contact works. So from the element faces in the source region, the normal gets projected, and Nastran will create a contact element if any of that source element normal intersects with an element in the target region, or if the distance between the two faces is equal to or less than your defined separation distance from that property as we saw. A couple of notes here. Again, since linear statics assumes small deflections, the number of contact elements created at that first initial step remains the same, so it does not change. Whereas in the advanced nonlinear solutions, the number of contact elements can change. So again, think something sliding or something like you see here, something coming down. Of course, the number of contact elements will be changing in this iterative solution. All right, now let's talk about connectors. These determine which regions and properties are related. So you can choose them from the drop-down windows you see here, or you can create them on the fly, which is very nice again. So here, this button to the right of the property will let you create that on the fly, or the define region will let you create new regions on the fly. And the edit buttons here simply let you edit the ones that you have selected here in the drop-downs for the regions. Now, there is a recommendation for which one is which. So the region with the finer mesh should be the slave or the source. So here we see a couple examples. A on the top, A is of course, the coarser mesh. B is the finer mesh, so that should be the source, and vice versa. So another important thing is this is very easy to switch as well. You can simply right-click in the model info tree on that connector and flip which one is the source or the slave. And again, this is only important if the meshes are very different in size. If they're pretty close to each other, it shouldn't make much of a difference. Another important note is you should not create contact regions and connectors that aren't tangent continuous, like in this case here. You'll see non-uniform stress results around those corners. So really what you should do is break these areas into multiple regions and connectors, as you see in the top image here. Also, don't include the same element in multiple regions. So in this beam you see here on the top, we have region 1, which actually has 3 elements, and then on the bottom side we have 2 regions, and that middle element is actually in 2 regions. So that's what you should not do. In case B here on the bottom, you see the correct way to do this. So region 1 can have 3 elements, that's fine. But then on the bottom, you can have region 2 with 2, and then a third region with just that last one there. And then you'd have 2 connectors, of course, connecting the top region 1 to 2, and then 1 to 3. All right, so I'll show you guys this in a minute in the demo, but as far as contact convergence, you will get a table written in the FO6 file, which gives you some information on that contact convergence. So you can watch this in the monitor window. If you see it diverging or going up here, you can hit the kill job button. And also the FO6 file will give you, again, more detailed information. So you can look at the convergence ratio, which should be decreasing with each iteration. All right, so here we're ready for the demo now. So here's the model that I'll be showing you guys today. On the left, we see the actual geometry itself. So as we can see, there's two brackets there. On the top bracket, there is actually a motor hanging from there. And what we're going to do is model that with plates here, and we've already got that modeled, of course. And the motor is actually represented with a simple mass element, since we don't need to worry about meshing and modeling the actual geometry of that motor. We just use a mass element which is connected with an RB2 or 3. All right, so let's go ahead and jump into Femap. Here we can see those two brackets are already meshed. If I rotate around, notice you can see that mass element here in the center, which is connected to the holes on the top of that bracket with a rigid body element. All right, as for constraints, we can see, I'll turn on the highlighter tool. We can see a constraint on the bottom surfaces, and there you can already see that normal option. I'll just turn that off for now and show you guys a few other things. So we have a load, which is just a gravity load going up, as you can see here, near the coordinate system. So that's basically the model that we have here. As I mentioned, we have a few different ways to create our connections. Here in the model info tree, you have the connections group. You can right click, like I mentioned, and do the automatic, or there's also the connect toolbar menu up here. So you have the same automatic button and all the manual commands here as well. I'll just use the model info tree. And for this first one, we'll do a glued connection here. And I'm just going to do the automatic method. I'll just select all, both of these bodies here. I want to do a face-to-face connection here, which is glued. And for the tolerance here, I just need to make sure, again, that I get that gap distance. In this case, it's 2. And as you can see, it calculates and instantly creates all of that for me. So again, these are the 3 different things required. First is the property. So just to show you, we can see at the top the type is glued. There's a search distance that actually just set it to 4, and it basically has all of the defaults. Then it created 2 regions. And here again, I'll turn on the normals. Using the highlighter tool right in the model info tree, I can show the normals. And now when I click the regions, you can see the normals. So in this case, the bottom surface is pointing up as it should, which is coming into contact with those top, the surfaces on the feet of the top bracket, which is pointing down. So that's correct. Both of the normals are facing each other. And the last part is the connector. So again, here, this is what connects all 3 of these. So it connects the 2 regions, as you can see here, 1 and 2, the master and the slave, with the property that was also created automatically. And that's really it for a glue connection. So I can go ahead and solve this. And here you can see, as usual, your analysis monitor window pops up. So you can drag this out if needed and look at the log file, see what's going on with your computer, look at the FO4 file, FO6 file, and in just a few seconds, this one is done. The sparse matrix solver just shows you all the equations it's solving. But this is already done, so I can just go ahead and close that and start looking at some of these results here. So I'll turn on deformed and contour plots here, and also turn off the filled edges so we can see those colors a little bit better. We can see there's some stress concentrations here at the tips of those feet. If I animate this plot, you can see, of course, an exaggerated plot in this case, but you can see what's going on. There's, of course, a rigid connection, again, is what this glued connection is doing. And again, the load applied here was just a 1G load going up, so it's getting pulled in the negative Y direction. So that's why you can see some stress, some high stress here in the corners. All right, so now let's see how easy it is to switch to a linear contact solution here in this case. So what I'm going to do is just turn off the results, and I will simply delete all my connections and basically start from scratch here with this new connection. All right, so first thing I'll do is create a couple of holes to create, bolts to connect these holes and brackets. So under the meshing custom tools menu, we have a hole-to-hole fastener. In here, all you need to do is select the 4 curves on the bottom hole. And as usual, you want to use the highlighter button just to make sure you get the right curves that you want it to. And the second step is to select the 4 curves on the top hole. And what that does is it creates a couple of spider elements, RBEs, and connects them with a bolt, basically, or beam. In this case, I will select, again, the 4 bottom curves for the bottom bracket and accept that. And the second step is to choose the 4 curves on the top. Very quickly, I've created some bolts to connect these two brackets, and now we can go ahead and connect them, create the linear contact. So I'll right click on connectors and new. I'm just going to create them on the fly here. So I'll create a new property. This is going to be contact. So I'll just press defaults. I want to type in maybe 0.2 for friction and the maximum contact search, let's say 2. And I'll go ahead and accept that. And I'll define some regions on the fly again. So here I want to pick surfaces just to make it a little bit easier. And I can hit the add multiple and simply fence select. We'll go to, let's see, yeah, that'll work. View here. And make sure we grab these elements, or surfaces really, but again, that's translating it to the element faces, of course, for us. I'll hit OK there, and that's created our first, and we can already see the normals, by the way, which are pointing in the right direction. So I'll hit OK there and select that for the first region, and I'll define another region and select just a large bottom surface. There you can see the normal is actually pointing up already for us. So I'll just select that for the second region and hit OK. And again, manually this time instead of automatic, I've created the property required, the two regions, and the connector that ties all those together. So I'll go ahead and solve this one again. And this takes about a minute to solve. Of course, I could have created those regions a little bit more specifically, right? I could have made those smaller so it doesn't have so many surfaces and elements to calculate and think about. But in this case, since we are doing linear contact and not glued, we get an additional button here in our NAS trend analysis monitor. So as usual, we have the log file, FO4, FO6, sparse matrix solver, and then we have this contact convergence. So as we can see, it's got a lot to calculate here because of how big I selected those regions, but that's fine. So we can see it start decreasing. Now this is where if something was defined incorrectly and you see this contact going up or diverging, you could just press this kill job button and save yourself some time and do some troubleshooting, figure out what went wrong. And in the FO6 file, you can see the convergence ratios here, 6.69 to the negative third, 6.49, and so on. So you can see it's decreasing with each iteration as it solves, which elements are in and out of contact. All right, so this is done solving. So let's look at the difference in results here. Let's turn on our deformed and contour plots again. And let's turn off those element edges so we can see these colors a little bit better. Now this is the first solution. So again, with the glued connection, we had some high stresses here in the corners at the tips of the feet. But with the second solution, with the contact, we can see much different stress results here. We're looking at plate Taubamisi stress. So we can see there's some stresses at the holes. And the results you want to look at when you're doing contact is, of course, something like contact pressure. So in this case, since we had the load going up, that motor and bracket were getting pulled up in this case, we, of course, see some contact pressure at the tips of those feet as expected. Now, if the load were going down, we would see that contact pressure at these two curves here, at these surfaces, which would be hitting the larger bottom surface. With that, let's go back to the slides here. So to wrap up, linear or glued contact is suitable for many situations, but you do want to keep in mind if the model may need to go into a nonlinear solution. Also remember, linear contact is supported in the linear solutions like static, modal, and in the multi-step and advanced nonlinear solutions, but not the basic nonlinear. This is all much easier than doing gap elements, springs, welds, and other things like that. And the nice thing is that Femap really simplifies the process for you with the default properties when you're defining either the glued or contact property. Also, just being able to use surfaces to define those regions, and it automatically applies it to the element faces for you. And also the fact that you're able to very quickly reverse the normal directions of the regions and also even flip the connectors as well if you want to swap the master and slave. All right, so with that, I'll hand it back over to Andrea to talk about the next section and wrap up.
Okay, actually, we are a little bit over time, but we do have a couple of questions, and if anyone else has questions, please go ahead and type them over in the questions tab over on the right-hand side. So George wanted to know, is it possible to define contacts that ties two surfaces normal to the surface, tension and compression, while allowing frictionless sliding along the surface's directions?
Great question. Yeah, so that's definitely, you know, you're talking about full-blown surface-to-surface sliding contact, which is an advanced nonlinear solution. Yeah.
Okay, perfect. And George, please go ahead and comment in the survey afterwards if you need more clarification on that, and we can always reach out to you afterwards. Jeffrey wants to know, what does the shell Z offset option do? When is it needed or not needed?
That just depends on your model. Depending on the parts and how you model your mid surfaces for thin walled parts. You know, you may include offsets or not, just to get things to line up properly. So if you have offsets, that's when you may want to, you know, change that shell offset setting for the contact.
Okay. Anthony wants to know, the example looked like it had two fatal errors. Can you talk about that?
Sure. Yeah, those are just user rights on my C drive. It was just yeah, properties on my hard drive.
Okay. And then what if the slave and master regions are wrong for a connector?
Great question. So on the, if I just jump back into Femap here in the model input tree under the connector. So again, this is important if you if the mesh densities, and let me just turn the mesh or the edges back on here so you can see. So if one region was, you know, if the elements on one region were much smaller or larger than the other, then you could simply right-click that connector and choose reverse. So that would simply swap the master and slave.
Okay. Joseph wants to know, can linear, contact, or glued surface be used to model a connection where bond surface coverage is not 100% or uncertain?
Let's see. So it sounds like that. You do have options in your properties for if it was a glued contact, there's a glue factor. So by default, it's actually 1. So it sounds like that's something you could play with there if you don't have full, you know, full bond on the entire surface. So you could play with that glue factor, you know, bumping down from 1. Or with the advanced nonlinear solutions, there's some additional settings there, and yeah, that's something we can talk about offline. So yeah, please reach out to us if you'd like.
Okay. Aaron wants to know, is there a way to easily view the contacts elements used and the surface/solid elements that they are connected to, i.e. node numbers between contact elements?
So sorry, can you repeat that one more time?
Yeah,
I think,
like for an example, node numbers between contact elements. So is there a way to easily see the contacts elements used and the surface/solid elements that they are connected to?
okay, yeah, I think I understand. So I believe you're just trying to see the actual elements or nodes that are coming into contact, and yes, all that information does get written out to your Nastran log files.
Okay. And again, guys, if we weren't able to fully answer your questions, we will be following up with the link to the session probably by tomorrow. So you can always reply to that email. It'll go straight to me, and I'll make sure that Dan gets that and we can fully answer your questions. But if there's nothing else, we can go ahead and move on. So our next session is also going to be on Femap this month, May 17th. Our other Dan Nato, will be presenting. And he'll be talking about using Femap and NX Nastran to identify and fix model issues. So make sure that you go to our events tab at saratech.com and make sure that you register for that. And like I said earlier, even if you can't attend, go ahead and register for it, and we'll send the link out to you. Next slide, Dan. All right. We also offer engineering services, training, and of course, additive manufacturing is really, really popular right now. We have 3 different partners that we work with: Markforged, HP, and Big Rep. If you have any questions about any of that, we will be happy to send over some information for you. And just make sure to follow us on all of our social media, especially YouTube. That's when we're going to be posting lots of shorter videos. These are obviously a little bit longer for these sessions, but we're going to be posting some shorter videos to kind of hone in on some specific details within our, lots of different software that we provide. And thank you so much for joining us today. If you have any extra questions, there is a quick survey right after we log off here. And please put your questions, comments, let us know how we did today. We really, really would appreciate it. Femap seems to be a really popular topic. So I'm hoping that we can get more Femap subjects coming in the coming months. So if you have any suggestions for future sessions, please put that in there as well. And thanks so much, everyone. Have a great day and a great Friday tomorrow, and we will see you hopefully very soon.